Okay, so in this problem, we're asked to find the second derivative of a function, and we're given the first derivative right here. So obviously the second derivative is the derivative of the first. This is still an implicit differentiation problem though, because there's y's and x's mixed in. So what I'm going to do is I'm going to start by rewriting that derivative in the Newton notation. So d by dx is f prime, and then y is f of x, and then we're multiplying that by 6 minus 2x. So I'm going to take the derivative of both sides. The derivative of f prime is f double prime. And then that would equal, when I take the derivative of this thing, that's going to require the product rule and the chain rule inside. So we're going to do first times the derivative of 6 minus 2x, which is negative 2, plus 6 minus 2x, which is the second thing, times the derivative of f of x squared, which would require the chain rule. So the outside function there is x squared. The inside function is f of x. So the derivative of x squared is 2x, and the derivative of f of x is f prime. I plug that into this, so that gives me 2 times f of x, and then multiply by the derivative of what's inside. So then my second derivative overall is, I'm going to move this stuff down. Like that. And then I want to find the second derivative. So I'm going to go ahead and move this back into the Leibniz notation before I do this, just so I can see it a little more clearly. All right, now we're trying to find the value of the second derivative at the point 3 1/4. So obviously we're going to plug in 1/4 for all the y's and 3 for all the x's. Now, normally we would need to find dy dx, and we would need to find it at the point 3 1/4. Now, normally the way we would do that is we would plug 3 1/4 into the first derivative, get that number, and plug it in here. Now, the reason I say normally is because in this particular problem, we've got negative 1/2 plus, and then this thing is 0 times that, so that whole term is going to be 0 anyway. So the second derivative is going to be negative 1/2, so we don't really need to find the dy dx this time, but normally we would. So the second derivative on this is negative 1/2.